Hey guys, this is Unit 2, Lesson 2, and we are going to be talking about reference angles today. So I think the best way to do that is show you what I'm talking about. So first of all, let's go ahead and do the definition. So the definition of a reference angle is a positive acute angle represented by theta prime. So theta prime is going to be always acute. And so I want to show you why this is. So we have this interactive here. So notice in the first, we have our coordinate plane here. So in the first quadrant, notice that my two angles that it's showing are both 31 degrees. Um, that's no big deal. But let's go over to the second quadrant. So I have, in actuality, a 150-degree angle, but my reference angle is going to be 27 degrees. So that's that angle that I'm going to use to find the 6 trig function. So we've kind of already seen this in the past, but we haven't really gone into it very much. So that 27 degrees is going to be my reference angle. So let's go down in the third quadrant. Um, so my actual angle is 200, but my reference angle is 20. So what I want you to notice about every single time I do this, it's in reference to the x-axis, never the y-axis. I don't care how close I get to the y-axis, it's never in reference to that. Okay, so over here, I have 349 degrees, and my reference angle is going to be 11. So the reason I'm showing this to you in each quadrant is because we are going to come up with a rule for each one of them. So start thinking about that. Okay, so in quadrant 1, we found that, let's flip back to quadrant 1. We found that the actual angle and the reference angles will always be the same. So actual angle is the same as a reference angle. And so if you'll notice, the actual angle is 55 degrees and the reference angle is 55 degrees. Okay, so I want to look at quadrant 2. So let's flip over. So when we move over to quadrant 2, think about a rule that we can come up with for any angle that lands in quadrant 2. So I want you to start thinking about it. Okay, so I think we're going to say, so think about, let's think about this one. So if you're looking at this, so it's 150 degrees and my reference angle is 30. If I'm trying to get to that 30-degree angle, I think I'm going to say 180 minus my angle, and that's going to give me my reference angle. So let's go back there and add that. So I showed 3 examples here, one just normal, one a negative degree, and one a degree with the rotation involved in it. So at its basic level, I'm going to take 180 minus 140, and I'm going to find that this reference angle right here is 40 degrees. So for this one, I'm going to take negative 200 plus 360 and get 160 degrees. So I know that this angle is 160 degrees, and this angle is going to be 20 degrees. So that reference angle is going to be 20 degrees. This 475, that's too big, so I need to take away the rotation, and I get 115 degrees. So 180 minus 115 is 65. So that's going to be that reference angle right there. Okay, so let's go down to quadrant 3, and I want you to think about the same thing. So I'm going to go down, let's make this a nice number. I'm going to go down here. So I have 200-degree angle and a 20-degree reference angle. So think about what that could be. Okay, so could we say theta minus 180? So let's do this. 200 minus 180 is going to give us 20. So that's what we want. Okay, so I came up with 2 examples here, negative 105 and 190. So negative 105, that's too small. So I'm going to add 360 to it, and ends up being 255. So I'm going to take 255, subtract 180, and this angle measurement right here is 75 degrees. Same thing over here. I have 190. I'm going to subtract 180, and I get this reference angle is going to be 10 degrees. Okay, so let's finally go down in quadrant 4, and I'm going to flip over. So over here, Okay, so I have 340 degrees for my actual angle, and I'm trying to get to 20 degrees for my reference angle. So we're going to take 360 minus the angle. So I have these three measurements, 307 degrees, negative 44 degrees, and 697 degrees. And I want you to kind of do what I've been doing, and I want you to find the reference angle for each of those. Okay, and you should have gotten those three angle measurements. Um, I want to talk about this one. So you can do this if that's your comfort level, but I also want you to see when you're going down negative 44 degrees, that's going to be your reference angle as well. So reference angles are always positive, um, but I just wanted you to kind of visualize that as well. So what we're going to do next is we're going to determine the exact value of each expression. So now we have a little bit more room to do more stuff. And so let's go from there. So sine of negative 150. I'm going to add 360 to that, and I get the sine of 210 degrees. Well, 210 degrees, that is going to give us a reference angle. So let's think about this. So this is 180, 210 degrees, that's a reference angle of 30. So let me write that down. Reference angle of 30. So I can treat this as a 30, 60, 90 degree triangle and grab those. So the sine of 210 degrees is the same as a sine of 30 degrees. It might differ, like one might be positive, one might be negative, but it's the same kind of values for each one. So I can look at it as such. So we know that the sine of 30 degrees is 1/2, but it's in quadrant 3, and I know that sine is negative in quadrant 3. So it's going to be negative 1/2. So that's that thought process there. Try to do number 2 on your own. Okay, let's go on to cotangent of 780. So the first thing I notice is that that's way too big. So I'm going to subtract 360 from it, and I get 420, and that's still too big. So I'm going to subtract 360 from that, and I get 60 degrees. So I'm looking at the cotangent of 60 degrees. So let's kind of put this into perspective. So I'm in that first quadrant, so I know it's going to be positive. Okay, so cotangent is 1 over the tangent of 60 degrees, and the tangent of 60 degrees is the square root of 3. So it's going to be 1 over the square root of 3 or square root of 3 over 3. So my final answer is going to be square root of 3 over 3. So notice that this and this are going to be the exact same answer. So that's how we can do that with our special angles. Okay, so let's try number 3. So as I've said before, the sine of 45 degrees squared, that's what that notation means. And then cosine of 135 squared. Okay, so the sine of, the sine of 45, that's going to be the square root of 2 over 2. And we're going to square it. Okay, the cosine of 135. So let's see, 135 is in here, and that's going to be a 45-degree reference angle. So the cosine of 45 degrees is also square root of 2 over 2. So I have 3 over square root of 2 over 2 squared. So this very quickly becomes, oh, and it's, sorry, it's in quadrant 2, so it's going to be negative. That's not going to affect our final answer, but I just want to make sure I put that in there. So this becomes just an algebra problem from here. So if I square this, I get square root of 2 times square root of 2 is 2. 2 times 2 is 4. I know you can simplify that, and you can. So same thing. I'm going to have 2 over 4, because when you square negative, it becomes a positive. So I have 2 fourths plus 6 fourths equals 8 fourths, or 2. So 2 is my final answer there. Okay, so let's go the other direction. So I need to know which angles deal with 1/2. So think about just like generic sine equals 1/2. So which angles? Is that going to be 30-degree reference angles, 45-degree reference angles, or 60-degree reference angles? And so I know that my reference angle is going to be 30 degrees. So now I'm going to go backwards. I'm going to use a couple hints. So there's always two places that your trig function is going to be positive and two places going to be negative. So sine is positive in 1 and 2 and negative in 3 and 4. So I'm going to find what's going on in 3 and in quadrant 4. So in quadrant 3, if I have a 30-degree reference angle in quadrant 3, I have 180 plus 30, and that's going to be 210 degrees. In quadrant 4, I have 360 minus 30, which is 330 degrees. So let's go backwards. So that's my answer. If I were to type in the sine of 210 in let's say my calculator, I'm going to get negative 1/2. And also the sine of 330, I'm going to get negative 1/2. Okay, so try 2 and 3. Okay, so for these last two, this is just like number 1. And so I found out that my reference angle was 60. I also found out that it was positive in 1 and 3, and I just went from there. Um, number 3 talks about a quadrantal angle because the cotangent is 0. So the first thing I did is I changed it to tangent because that's just where my frame of mind needs to be. So if I knew that it was undefined, I knew that I had a 0 on the bottom. So what I did is I went to the coordinate plane and figured out where is y over x, give me a 0 on the bottom. And so that is these two right here. So I end up with 90 and 270. And that's it.